Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रु तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज रो टॉपिक रे हमें फर्स्ट एंड सेकंड ऑर्डर फेज ट्रांजिशंस विथ एग्जांपल्स आता सहित एरेनफेस्ट इक्वेशंस विषय रे पढिबा तो देखो ये जो फेज कहले हमें कोन बुझिबा जनरली गोटे सब्सटेंस तीनटा फेज रे रही थाए मे बी सॉलिड और लिक्विड और गैस किबा वेपर जोटा सो ये जो फेज चेंज होची गोटे स्टेट रु आ गोटे स्टेट को okay it is like transition from solid to liquid state or liquid to vapor state or solid to vapor state and this transition is known as your first order phase transition acha a first order phase transition रे there is always absorption or emission of certain quantity of heat which is known as latent heat per unit mass when this first order phase transition takes place. Now with this the entropy of the system also changes and also the volume of the system changes abruptly as a result of this first order phase transition. Kintu second order phase transition कहले here no latent heat is involved nor the entropy or your volume of the system changes. Okay, so these becomes constant. Okay, here in case of second order phase transition latent heat, entropy and volume are unchanged. Okay, so the transition of a superconducting medium to an ordinary conductor or transition of a ferromagnetic material to paramagnetic material at your Curie temperature, which is the transition temperature, are some of the best examples of your second order phase transition. तो आगे आम फास्ट ऑर्डर फेज ट्रांजिशन विषय रे देखिबा देखो इन ए फर्स्ट ऑर्डर phase transition here the changes takes place at a fixed value of temperature and pressure so the change in temperature and pressure are 0 okay and we call this process of phase transition as an isothermal because temperature constant and isobaric because pressure is constant so isothermal isobaric process madhya yaku kuha jaye now according to Maxwell's thermodynamic relation जोटा आम गिब्स फंक्शन देखुला डी जी इक्वल टू माइनस एस डी टी प्लस भी डी पी यार भैल्यूटा आसला अच्छा एठी डी जी becomes equal to 0 because dt आउ dp एटा चेंज होनी टेम्परेचर ऑफ प्रेशर कांस्टेंट अछि सो dg रे मध्ये 0 हबो thus the Gibbs potential g which is a function of t and p is now del g by del t at constant p which is equal to minus s and del g by del p at constant t which is equal to v. Okay, now let us suppose that the system consists of a substance containing two phases. Okay, suppose phase 1 and phase 2 duita phase emti achi such that they are in equilibrium. Now let the mass of the substance in phase 1 be m1 and phase 2 be m2 in the state of equilibrium. Similarly, let small g1 and g2 be the values of your Gibbs function per unit mass of the phase 1 and 2 respectively such that the Gibbs function for the entire system becomes now capital G, okay, entire system by capital G which is equal to m1 g1 plus m2 g2. Acha. Now if g1 and g2 are constants then on differentiating this equation dg becomes equal to dm1 g1 plus dm2 g2 and for an infinitesimal phase change the changes in m1 and m2 that is these two becomes very small, so that we can consider their summation dm1 plus dm2 to be equal to 0, so that dg becomes equal to 0. d0 value आमे put करिबा याकू जदि आमे solve करी करी जिबा putting dm1 equal to minus dm2, then we will get g1 equal to g2. So g1 equal to g2 mane asila, so it implies that the Gibbs function per unit mass has the same value for the two phases. Okay, acha. Now the temperature T at which the phase transition takes place is depending upon the pressure, and if there is a change in pressure from P to P plus dP, then the two phases will come to equilibrium at a new temperature, which is T plus dt. Accordingly, the values of G1 and G2 will also change to G1 plus dG1 and G2 plus dG2. Again, for the case of equilibrium, these two must be equal. Okay, yaku ame equate kariba, and we will put G1 equal to G2, so eta duita katigala, so asila kono dG1 equal to dG2. But we know that the Gibbs function g is also a function of temperature and pressure. Okay, so यार partial differentiation हिसाब रे dg1 और dg2 रो value accordingly आमे पाई परिबा एई दुइटा समान एसछि हमर ए रिलेशन रे, सो दुइटा को आमे इक्वेट करिबा एबे. ओके, एबे आमे पुणी जानिचु ऊपर जो इक्वेशन 1 और 2 रु देखुतला गिब्स फंक्शन रो वैल्यू पार्शियल डेरिवेटिव रे जेतेबेले आमे ऑपरेट करूछु टेम्परेचर आउ प्रेशर, ताले del g by del t होतला माइनस s आउ del g by del p होतला v. ओके, सो अकॉर्डिंगली g1 g2 पाई अकॉर्डिंगली आमे एठी चारिटा रिलेशन पाइला, where s1 s2 and v1 v2 are the entropies per unit mass of the substance in phase 1 and phase 2, and volumes per unit mass of the substance in phase 1 and phase 2 respectively. So एई जते सब वैल्यूज आमे पाइला ताकू जदि आमे पुणी इक्वेशन जो ऊपर देखुतिला सेठी पुट करिबा इक्वेट करिबा, then finally we will get the value like this. एठी आमे डायरेक्ट dg equal to minus sdt plus vdp एई भलिया भी पुट करि परिबा. ओके, सो याकू सॉल्व करी करी जिबा जदि we will get dp by dt equal to s2 minus s1 divided by v2 minus v1. Okay, now yaku gote equation de deba ame. Now the latent heat L, which is the amount of heat per unit mass given to the system or extracted from it during a small change in the phase, yaku ame lekhi pariba latent heat L equal to T into the change in entropy, that is S2 minus S1. Okay, so एठी dq equal to tds एई जो सेकंड लॉ ऑफ थर्मोडायनामिक्स एटा यूज करछु और dq जगह में l पुट करछु. ओके, सो s2 minus s1 रो वैल्यू आसिला केते ना l by t, याकू आमे एई जो न्यूमरेटर रे s2 minus s1 अछि से जगह रे पुट करिबा. So by putting we get dp by dt equal to l by t into v2 minus v1, which is the general equation governing the first order phase transition. Okay, and in fact it is the famous Clapeyron's latent heat equation. Okay, so when we apply this equation to the equilibrium between the liquid and gaseous phase, the equation becomes the famous Clapeyron's latent heat equation, which we had derived on the basis of Maxwell's relation ya purvaru. Okay, so dp by dt at the saturation point is now L2 by T2 into Vg minus Vl. G stands for your gas and L stands for liquid, where Vg and Vl are the volume per unit mass of the substance in the gaseous and liquid phases at the transition temperature T2. Similarly, L2 is the latent heat of vaporization, which is defined as the amount of heat required to convert unit mass of liquid to gaseous phase. Okay, so similarly ebe ame jodi amount of heat required to convert unit mass of solid to liquid phase taku bahar kariba, then it will be latent heat of fusion. So yaku jodi L1 कहला ame, ताले dp by dt becomes equal to L1 by T1 into VL minus Vs. Also, for the transition between solid to gaseous phases, the latent heat is known as latent heat of sublimation, which is L3. যদি আমি ইয়াকু L3 কহিলা তাহলে dP by dt at the saturation is L3 by T3 into Vg minus Vs. Okay, so ଆମେ ତିନିଟା transition এই হিসাବରେ ଦେଖିଲା. Now the above three equations represents the slopes of the curves in a graph. Okay, ଏଠି ଦେଖ figure ରେ ଆମେ pressure को y axis रे नेइछु, temperature को x axis रे नेइछु, where we have plotted the graph like this, and the fusion curve is this one, this is the vaporization curve, and this is the sublimation curve. Okay, এটা আসছে liquid, এটা solid, আর এটা gas. So if G solid is equal to G liquid, then the curve OC, this one, okay, this curve represents the phenomenon of fusion. Similarly, if G liquid is equal to G gas, then the curve OB represents the vaporization. And the last, G gas is equal to G solid jodi hochi, then the curve OA represents the sublimation. Okay, so এଠି ଯୋଉ common point ଟା ରହୁଛି ଏଇ ଯୋଉ O, okay, which is common to vaporization, fusion and sublimation. So here the three curves meet and it is known as triple point. Okay, hence all the three phases coexist in this point O, and G solid equal to G liquid, which is equal to G gas at this point, at the triple point. Okay, now the graphs of G versus temperature, then entropy versus temperature, and volume versus temperature are shown in below, where it indicates that the first order phase transition, here there is a discontinuity. Okay, discontinuity ରହୁଛି first order derivatives of the Gibbs function. So ଦେଖ ଏଠି କେବଳ ତମର common point ରେ ଏଠି meet କରୁଛି phase 1 ଆଉ phase 2, କିନ୍ତୁ ଏଠି ଦେଖ phase 1 ଟା ଏଠି ଆସୁଛି, phase 2 ଟା ଏଠି ଆସୁଛି, so there is no common point. So ଏଠି ଆମେ ଦେଖିଲା ଯେ entropy which is minus del G by del T, ଏଠି discontinuity ରହୁଛି. Similarly volume which is del G by del P, ଏଠି ବି ସେଇ ଭଳିଆ phase 1 ଏଠି, phase 2 ଏଠି, so ଏଠି କିଛି common point ନାହିଁ, so there is discontinuity. Okay, continuity କେବଳ ରହୁଛି ଏଇ ଯୋଉ Gibbs function ପାଇଁ, okay, with respect to your temperature. अच्छा, तो ये ହେଲା ତମର ଯୋଉ first order phase transition. Now in these processes there is actually the transference of heat, and hence there is change in entropy and volume. Therefore a first order phase transition can be defined as that where the Gibbs function with respect to pressure and temperature changes discontinuously. Okay, जो आमे देखिला there is no common point. Okay, transition point रे एमानक भितरे discontinuity रहिबो first order phase transition रे. Okay, जदि आमे Gibbs function को देखुछु. However, the value of Gibbs function is same in both the phases at equilibrium. Okay, so these changes are represented graphically in the above figure. Now first order phase transition रो जदि आमे किछटा examples नेबा ताले जदि आमे water को heat करूछु at the boiling point temperature, that is 100 degrees Celsius, and pressure 1 atmospheric pressure, then it changes from liquid to vapor, eta ame janichu. Now the density of water is 1000 kg per meter cube, while that of your vapor is 0.6 kg per meter cube. Therefore the transformation of water into vapor at constant temperature and volume is first order phase transition. देखो एठी जेहेतु density टा दुईटा जाकर अलगा अलगा रहुची, and hence volume is different. Okay, similarly the transformation from ice to water at the fusion point 0 degree Celsius and 1 atmospheric pressure is also an example of first order phase transition. Okay, अच्छा, first order phase transition देखिला परे एबे देखिबा हमें second order phase transition आउ सेथिरु हमें Ehrenfest equation बाहर करिबा. देखो किछटा recent investigation रु जणा पड़ला जे during the phase change or phase transition there is no transference of heat and there is no change of volume. गोटे यार एग्जांपल है जिते लिक्विड हीलियम 1 लिक्विड हीलियम 2 को ट्रांजिशन होउची then also there is no transfer of heat, no change in volume. So such type of transitions are called second order phase transition, where the entropy and volume are not changed and it takes place at constant temperature and pressure. यार किछटा एग्जांपल्स जदि आमे देखिबा ताले देखो नंबर 1 जेमति आमे देखिला transition of liquid helium 1 to liquid helium 2 at lambda point, that is 2.19 Kelvin. Then number 2, transition of a ferromagnetic material to a paramagnetic material at Curie point. Number 3, transition of a superconducting metal into an ordinary conductor in the absence of magnetic field. Number 4, এটা হচ্ছে গোটে order disorder transition जोटा chemical compounds आउ alloys रे ही थाए. एबे देखो आमे जो previous first order phase transition रे ग्राफ देखुतिला ताकू जदि एबे second order transition पई plot करिबा Gibbs function, entropy आउ volume रो, then we can easily see that there is no discontinuity. Okay, there is absolutely continuous plots. Okay, so जेमती कटि जाउतला at the transition point, okay, discontinuity रहउतला first order phase transition रे जेतेबेले आमे एई गिब्स फंक्शन रो फर्स्ट ऑर्डर डेरिवेटिव देखुतिला किंतु देखो एई दुई केस रे एबे कंटिन्यूटी आसी जाईछि. ओके, सो याको आमे एबे मैथमेटिकली लिखि परिबा. So from these three graphs we can see at the phase transition point, first graph रो आमे पाउछु g1 equal to g2, so that g2 minus g1 equal to 0. तापरे second graph रो पाइला minus del g2 by del t plus del g1 by del t, which is s2 minus s1 and it is equal to 0. Okay, so entropy phase transition रे समान रहउछि. Okay, तापरे third graph रो del g2 by del p minus del g1 by del p, which is v2 minus v1 equal to 0. वॉल्यूम भी समान रहउछि. किंतु जदियो फर्स्ट ऑर्डर डेरिवेटिव गिब्स फंक्शन रो एटा कंटिन्यूटी रहउछि माने देयर इज नो डिसकंटिन्यूटी, किंतु सेकंड ऑर्डर डेरिवेटिव जदि आमे बाहर करिबा देन it changes discontinuously. सेटा हमें एबे आपको देखिबा. Now if we calculate the specific heat at constant pressure, that is Cp, which is T del S by del T at constant pressure, or Cp by T is del S by del T, और S रो वैल्यू जदि हमें एठी पुट कर देबा we get minus del square G by del T square. Okay, it is the second order derivative. तापरे गोटे आमे नेबा k होउछि एठी isothermal compressibility, which is minus 1 by v del v by del p, और kv is equal to minus del v by del p. v रो वैल्यू हमें पुट कर देबा, so we will get again a second order derivative, that is minus del square g by del p square. एटा आसिला kv रो वैल्यू. तापरे आ गोटे क्वांटिटी नेबा alpha, which is the volume coefficient of expansion. यार वैल्यू है 1 by v del v by del t. अल्फा v अकॉर्डिंगली आम बाहर करि परिबा. यार वैल्यू अगेन गोटे सेकंड ऑर्डर डेरिवेटिव आसीबो del square g by del t del p. ओके, नाउ जो आम एठी तीनटा इक्वेशन पाइला. ओके, cp पई गोटे, k पई गोटे और अल्फा पई गोटे. सो फर्स्ट इक्वेशन जोटा cp by t देखुतिला इक्वेशन 4 रो हैला आमे एठी cp1 by t और cp2 by t एही हिसाब रे लिखि परिबा. ओके, नाउ एबे कोन करिबा ए दुटा को आमे सब्ट्रैक्शन करिबा. ओके, सो cp1 minus cp2 by t यार वैल्यूटा एतकी आसिला. सिमिलरली फ्रॉम इक्वेशन 5 and 6 आमे सब्ट्रैक्शन जदि करूछु ताले देखो k पई और अल्फा पई अकॉर्डिंगली आमे दुटा इक्वेशन पाइला. Okay, now for second order phase transition there is no change in entropy and volume. Okay, entropy और volume टा change होनी जोथि पई हमें पाइला S1 equal to S2 और S1 plus ds1 equal to S2 plus ds2 at temperature T plus dt and pressure P plus dp. Okay, जदि change हे गला temperature और pressure ताले ds1 equal to ds2 हेबो. ओके, और ds जदि आमे याको पार्शियल डेरिवेटिव बाहर करिबा, ds माने s is a function of temperature and pressure, यार पार्शियल डेरिवेटिव ए हिसाब रे आसीबो यार वैल्यू आमे पाइछु cp/t यार वैल्यू आमे पाइछु dv/dt ओके सो accordingly याकू आमे एबे पुट करिबा dv/dt रो वैल्यू देखो एठी आसीगला v alpha 1 तापरे आकू आमे कैलकुलेट करी करी जिबा एठी गोटे जिंस करिबा कोन ना ds रो जो वैल्यूटा आमे पाइला दिस शुड बी v alpha 1 हेबोनी v alpha हेबो एटा ओके नाउ ds1 आउ ds2 এই দুইটা আমি সেপারেটলি লিখি পারিবা ওকে নাও ওয়ান্স ds1 ଆଉ ds2 পাইগলা পরে দুইটাକୁ ଏବେ ଆମେ ଇକ୍ୱେଟ୍ କରିଦେବା ବିକଜ ds1 ଇଜ ଇକ୍ୱାଲ ଟୁ ds2 ଓକେ ଇକ୍ୱେଟ୍ କରିସାରିଲା ପରେ ଦେଖ ଠିକ୍ ସେମିତି ଆମେ ଯେଉଁ ଫାର୍ଷ୍ଟ ଅର୍ଡର ଫେଜ୍ ଟ୍ରାଞ୍ଜିସନରେ ପାଉଥିଲା ସେଇଭଳିଆ ରିଲେସନ୍ ଏବେ ଆମେ ପାଇଯାଉଛୁ ସୋ ଏଠି ୟାକୁ ସଲ୍ଭ କରିଲେ ଆସିବ dp/dt ଇକ୍ୱାଲ ଟୁ cp2 minus cp1 by dv into alpha 2 minus alpha 1 okay similarly by assuming v1 equal to v2 for the second order phase transition so it will be dv1 equal to dv2 asibo accordingly again we will differentiate this volume partial derivative हिसाब रे या को लिखि परिबा रिप्लेस कर देबा फर्स्ट ऑर्डर पार्शियल डेरिवेटिव सो दैट आमे पाइला केते एट द एंड dp/dt equal to alpha 2 minus alpha 1 by k2 minus k1 okay so एठी जो दुईटा इक्वेशन आमे पाइला फर्स्ट हला ए जो ऊपर ए इक्वेशन टा दिस वन तापरे एठी आ गोटे इक्वेशन this one these two equations are called Ehrenfest equation and these equation represent the condition of equilibrium between the two phases okay तबे ये जो Ehrenfest equation को हमें अल्टरनेटिवली भी डेराइव करि परिबा एटा आ गोटे बही रे थिला मु एठी एडिट करछि सो जोटा तुमको इजी लागिबो तमे लिखि परिबो now for this we consider one of the limitation of Clausius-Clapeyron equation which states that the specific heat capacity and specific volume do not change in second order phase transition जेमति हमें ग्राफ रे देखुतिला so Ehrenfest derived some equation which relate the changes in specific heat capacity and the derivatives of specific volume in the second order phase transition so एथिपय हमें specific entropy को consider करिबा as a function of temperature and pressure now we differentiate so that in terms of partial derivative हमें यार relation एमती पाइला now we can see T del S by del T which is equal to Cp the specific heat at constant pressure ऊपर जेमती हमें देखुतिला आउ एठी जो ई del S by del P अछि याकू हमें मैक्सवेल्स थर्मोडायनामिक रिलेशन यूज करिकी माइनस del V by del T ए हिसाब रे लिखि परिबा so that एबे ds रो वैल्यू आसीगला this much okay now ds रो वैल्यू once पाइला परे हमें एठी second order phase transition रे देखुतिला जे there is continuity okay continuity of specific entropy okay so the entropy is constant तेणु करी ds रो value 0 हेबो there is no change in entropy or ds1 minus ds2 equal to 0 एठी जो 1 आउ 2 एटा correspond करूची दुईटा phase को phase 1 आउ phase 2 so ds1 आउ ds2 को हमें accordingly ए हिसाब रे लिखि परिबा now equating 1 and 2 we get this much okay याको equate जदि करिबा आकु ठीक सेही ऊपर जेमति हमें देखुतला सेही बळिया हमें सॉल्व करी करी जदि जिबा ताले we get delta cp by t which is equal to del v by del t at constant pressure into dp by dt हमें ऊपर जो रिलेशन टा पाइथिला dp by dt equal to something पाइथिला ओके एठी delta cp by t ए हिसाब रे लिखा हिची ओके सेम जिंस एठी अलगा अलगा बही रे अलगा अलगा वे रे लिखा हिता सो याकू ये फर्स्ट Ehrenfest equation कहूची okay similarly if we consider the specific entropy to be function of temperature and specific volume then we can derive the second Ehrenfest equation like this delta cv equal to minus t into delta del p by del t at constant volume into dv by dt okay and by taking into consideration that the specific entropy is a function of volume and pressure okay so जे कोनोसी दुईटा पैरामीटर रो फंक्शन नै कि हमें एटा बाहर करछु सो एठी वॉल्यूम और प्रेशर रो फंक्शन जदि हमें नउछु एज योर एंट्रोपी ताले थर्ड Ehrenfest इक्वेशन हमें पाइबा डेल्टा into del V by del T, which is equal to delta into del P by del T into dV by dP. Now finally, by considering the specific entropy to be the function of temperature and pressure, we obtain the fourth Ehrenfest equation, which is delta del V by del T, which is equal to minus delta into del V by del P into dP by dt. So a point here to remember that the transition between different magnetic states of metal cannot be described by these Ehrenfest's equation. Okay. Now এই Ehrenfest equation ভিতରୁ যদি ଆମେ first Ehrenfest equation ର ଯଦି ଗୋଟେ example ନେବା application, then we can determine the slope of phase boundary between the helium 1 and helium 2 as shown in figure. So ଏଠି figure ରେ ଲକ୍ଷ୍ୟ କର, this is the helium 1 region, this is the helium 2 region. Okay, so ଏଠି normal liquid phase କୁ ଆମେ refer କରୁଛୁ helium 1 ବୋଲି, ଆଉ ସୁପର ଫ୍ଲୁଇଡ୍ ଫେଜ୍କୁ ରେଫର କରୁଛୁ ହିଲିୟମ୍ 2 ବୋଲି। ଆଉ ଏଠି ଏଇ ଯେଉଁ ଫେଜ୍ ବାଉଣ୍ଡ୍ରି ଯେଉଁଟାକି ଦୁଇଟାକୁ ସେପାରେଟ୍ କରୁଛି, ଦିସ୍ ଇଜ୍ ୟୋର୍ ଲାମ୍ବଡ଼ା ଲାଇନ୍। ଓକେ, ଲାମ୍ବଡ଼ା ଲାଇନ୍ is the phase boundary for the second order phase change or phase transition between the two liquid phases. Now if the pressure is taken to be very large, then only solid phase, okay, solid phase of helium can be obtained। যদি high pressure ନେଇଗଲା ତାହେଲେ ଦେଖ ଏଠି okay, pressure ଟା ଯେତେ ଯେତେ ବଢ଼ି ବଢ଼ି ଯିବ ତାହେଲେ we can get the solid phase of helium, and here the pressure normally should be more than the atmospheric pressure. Okay, ଏଟା ଗୋଟେ ଆମେ application ଦେଖିଲା first Ehrenfest equation ର। some of the other examples of second order phase transition already ଆମେ ଏଟା ଦେଖିଛୁ। okay, number 1, transition of superconducting material to ordinary conductor in the absence of magnetic field, then order disorder transition in certain chemical compounds and alloys, and the third one, ferromagnetic to paramagnetic transition at the Curie point. These are some of the second order phase transitions example. Okay, so this is all about your first and second order phase transitions and Ehrenfest's equations.
Thank you.